Okay, sorry about that. So to represent in a table, we have our inputs and our outputs. So our inputs, as we remember, our n represents what number it is in the sequence. So if it's the first term, input is 1. So our first term is 2. For the second term, our input is 2. We have a 4. For our third term, we have an 8. And our fourth term, and our fifth term, and our sixth term. We could get these terms by remembering that we multiply by 2 each time. Multiply by 2, 16, and I'll let you guys finish the next two. Okay? So that's representing it as a table. The other way we could represent it is as a graph, right? So we've learned how to do that before. We actually have a chart right here that we're going to be able to graph with. And okay. There's my XY axis. 1, 2, 3, 4, 5, 6. I'm going to go by 2, 4, 6, 8, 10, 12, 18. Okay, I'll go by 2s on this axis. I'm going to go by 1s on this axis. Alright? So when we graph this, for our input of 1, we have an output of 2. For our input of 2, we have an output of 4. Input of 3, we have an output of 8. Input of 4, we have an output of 16. And so on. So the shape of these exponential functions or geometric sequences are actually curved. They're no longer straight. We're not dealing with a linear. They're actually a curve. So this one, if you notice, as we read from left to right, it's increasing, right? Or it's a positive. That's because we're multiplying by something each time. It's increasing each time. Okay, for this one down here, remember our ratio is 1 over 3, or we're dividing by 3 each time, so we're going to see what's different in our graphs. So our table is going to look really similar, n and f of n. Okay, our inputs, we have the first term, second term, third term, fourth term, fifth term, sixth term. Our first term is 18. Second term is 6. Third term is 2. 2 over 3. 2 over 6. Let you finish the last one. I'm basically dividing by 3 each time. And this is actually wrong. That should be 2 over 9. Okay. Alright, when we graph this out, because that's another way that we can represent our function, is by graphing it, just like we did up here. Remember that we are actually dividing by something each time. So we're going to see how it is different, how these two graphs are different when you have a ratio that's a division and a ratio that's addition. So I'm going to go by 2s on the y-axis, and I'm going to go by 1s on the x-axis. Alright, so for this graph here, when we graph it, we have all our coordinate points here. So 1, 18, 1, 18, 2, 6, 3, 2, 4, 2/3, 2 9s, and so on. So this exponential function is going to look like that. Notice it's not a straight line, it is a curve, and it's, when we read it from left to right, it is decreasing, right? Decreasing. That's because you're dividing by a factor of 3 each time, not multiplying. So it's getting smaller and smaller. Alright, so if I give you guys 2 different sequences, I'm going to go ahead and erase all this. Actually, I'm just going to erase these. I'm going to give you 2 sequences, and I want you to do exactly what we just did. So represent them as an equation, a table, and a graph. So first sequence, 3, 9, 27, etc. Okay, the next one, 36, 18, 9, etc. Okay? So remember, you're representing these as an equation, a table, and a graph, and you're doing it on the left-hand side. Alright, go ahead and pause the video now and get those completed. Okay, so you're back with me. You've already done those 2 with tables and graphs. Remember that your lines should not be a straight line. They should be curved because we're doing exponential functions, and that means that they are curving. Alright, 2 more of, no, 1 more of these. Just want to get one with a specific domain. So if you're given an equation, let's say your equation says f of x is equal to 20 times 1 over 2 to the n minus 1. Let's say that's your equation right there. Okay, so you need to be able to pull out of this, right, what is your first term of your sequence, and what is your ratio. So your first term is that number right there. That's what it's been from the equations, is 20. All right, and your ratio is 1 over 2, which remember means you're dividing by 2 each time. Okay, so if we were to try to write this as a sequence, we know that it starts with 20, and we know you're dividing by 2 each time. So the next one would be 10, 5, so on. Okay, that would be our sequence, representing our sequence. We could also represent it as a table. Okay, so as a table. And let's do it just in a different orientation so you guys get used to that. We'll have our inputs on the top and our outputs down below. 2, 3, 4, 5, 6. Okay, so our inputs, we have our first term, second term, third term, fourth term, fifth term, and sixth term. Right, let's see, our first term is 20, 10, 5, 5 over 2, or 2.5, 5 over 4, 1.25, and 5 over 8. Okay, those are our tables. And if we were to graph this, right, if we were to graph this, we would graph all of these coordinate points here. So 1, 20, so let's see, 1, 2, 3, 4, 5, 6. Going by ones on the x-axis, 3, 4, 6, 8, 10, 12, 14, 16, 18, 20. 18, 16, 14, 12, 10, 10. Going by 2's on the y-axis. So graphing this, you already know that since you're dividing by something, you know it's going to decrease, right? It's going to go down. It's going to almost have like a negative slope for this exponential graph. So 1, 20, 2, 10, 3, 5, 2.5, 1.25, and so on. And that's what your exponential graph would look like. Making sure that you put arrows at the end, because you do remember that these sequences, these geometric sequences, go on forever and ever and ever. That's what these 3 dots right here mean, is that they go on forever. Okay, last thing that we are going to do is we're going to actually figure out how to write equations when we are given 2 coordinate points. So, given 2 coordinate points that lie on a graph, how do you write an equation, and how can you represent it in the different formats? Okay, so coordinate points 2, 100, okay, and 3, 1000. Those are our coordinate points. So hopefully when you see these, you're already starting to think something about slope, something about seeing how much the x's are changing and the y's are changing, because that's typically what we do when we have 2 coordinate points. But we're going to switch it up a little, and we're going to just represent this in any way that we can. So we know that to get an equation, we need the first term, and we need the ratio. Unfortunately, we don't have either of those right now. What we have is we have the second term is 100, and the third term is 1000. That's all we've got so far. Okay, which doesn't give us either of the things that we need to find our equation. So we could look just at the sequence and try to work backwards and identify this. That might work. So let's think about what we're having to multiply by to get to 1000. Well, by 10. Right? And if you weren't sure about that, you could have done 1000 divided by 100, which equals 10. So the third number divided by the second number, which equaled that. Okay, so you think about, this also needs to be multiplied by 10 because it's a geometric sequence. So to work backwards, you would just divide by 10. So to work backwards, you would just divide by 10, which means that our first term is 10. So our first term up here is 10. And we actually found the ratio as well. The ratio is actually also 10. That's how much we're having to multiply by each time to get the next term. So if we wanted to represent this as a table, it would be pretty easy. We could, I'm going to do it in a different orientation. n and f of n. 1, 2, 3. I'm just going to do 4 this time. So the first term, second term, third term, fourth term has 10, 100, 1,000, 10,000. Okay? And this coordinate point 2 comma 100 is right here, and 3 comma 1,000 is right there. Alright, I'm going to have you do, well no, we're going to do one with fractions together, then I'll have you do two on your own. Let's see, I actually want you guys to do this one first. 3 comma 20 and 4 comma 40. Okay? So these are the two coordinate points that you have, and I want you to get me to an equation. Great. Alright, you're doing this on the left-hand side, so pause the video, get that done. Alright, we're going to do one with fractions, and then you're going to do one with fractions, and then you'll be done with this video. So we have the two coordinate points, -2, comma 2/5, and -1, comma 2. Alright, so for this case right here, we don't have the first term, because we have the negative second term and the negative first term. So what we need to do is I am going to first find the ratio, because we can find that by basically doing the same thing as we do for the slope. So we're thinking about how much we have to multiply 2/5 by to get 2. So we could also look at working backwards, and instead of figuring out what we need to multiply by, figuring out what we need to divide by. So 2 divided by 2/5, 2 divided by 2/5, right? Now you can always do that. That method always works. So okay, so when we do this, we're going to change this to multiplication, and we're going to flip this over. So division by a fraction is the same thing as multiplying by the reciprocal. We can change this 2 into a fraction, and when we do that, we have 2 times 5 is 10, 2 times 1 is 2, which means we get 5. So our ratio is equal to 5 in this case. So if you multiplied this by 5, you would get 2. Awesome. Alright, first, the thing that we still don't have is our first term. So we're going to look at a table and see if we can use that table to find our first term. So right now the coordinate points that we have are n is -2 and -1. And if we continue to just add 1 for the x's, that's how our chart would continue. So at -2, our y is 2/5. At -1, our y is 2. And we know our ratio now. We're multiplying by 5 each time. So our next one would be 10, 50, 250. So to write an equation for this, we would have f of n equals first term. Nope, first term is 50. Ratio is 5 times n minus 1. Remember, the first term is always when your x is 1. That's your first term of your sequence. Always when x is 1 or your input is 1. Okay? Alright, you have one last one for you guys to do. And then you will be done for this video. Okay. 2 coordinate points. 1 4/5 and 2 and 2/3. Alright, go ahead and give me an equation for using those 2 coordinate points. And once you're done with that, you do need to get 14.4 done today as well.